All right, hey guys, welcome back. We're going to do the second part of inverse function. But before we do that, let's review the first part. Remember, we had a cameo by Mr. Sulu. Thank you, Mr. Sulu. And what we saw was that when we reflected a point over the line y equal x, all it did was switch the coordinates. Okay, anyway, they switched. Just don't make that difficult. And we were able to do a problem like this. So you may want to pause the video and see what you can come up with. We were doing G inverse of 4. Keep in mind that is not the negative 1 power. That is read G inverse. All right, so what we did was we realized that this 4 is an x. It is x relative to G inverse. But it's y relative to G. And we have a picture of G. All right, and that's why we're drawing this line, because the y coordinate of every point on that line is 4. And we're dealing with the G function. So we're talking about that point right there. And then the other coordinate is -5. So G inverse of 4 is -5. Keep in mind, these questions are just describing a coordinate, and the answer is the other coordinate. All right, problem 2. See if you can come up with the answer. So F inverse of -1, that means we would draw that, and we're dealing with the F function. So we're right here, and -1 is that y coordinate, and the x coordinate is 2. So F inverse of -1 is 2. Okay, let's look at what we're doing today. And today we're writing the inverse of a function. Well, we've seen that when we reflected a point over the line y equal x, we just switched x and y. Well, that's what we're doing here. We're making this y, we're making this y x, and we're making this x y, and then that's it. That is it. Almost. The problem is that this is just not in mathematical format. It is not pleasing to the mathematician. If it's going to be pleasing to the mathematician, you've got to solve it for y. Well, everybody should know how to do that. You should know to add 4 to both sides. I'm just putting the +4 for effect. You don't have to do that. So that's x plus 4 equal 3y. Everybody should know to divide both sides by 3. And then, since this is a linear equation, I do want you to put it in slope-intercept form, which would be x over 3 plus 4/3 equals y, or 1/3 x plus 4/3 equal y. All right, and then that's it. I'm just going to point this out real quick. This is just recapping what we just did. We switched x and y. If you want to pause the video and read some of this, you can. All right, and then we just did that. Switch x and y, solve back for y. One thing you can do is that you can kind of pick a random number like 5 and input it, do an input-output of the original problem, and the output would be 11. Then you take this answer and do an input-output, but the input is 11 and the output would be 5. It switches the inputs and outputs. You can test that. It's just any random number. Let's do another one. Pause the video and see if you can do that. All right, we switch. Y becomes x and x becomes y, and then that's it. But then we want to be mathematically correct. So let's subtract 2 on both sides and take the square root of both sides. Now, we have a problem here that if we go back and we'll look at a simple graph of the original function, it is this, and it does fail the horizontal line test that we've talked about. So the inverse is not a function. And the way that manifests itself here is that would be a plus or minus there, but we just kind of consider just the plus. You limit the domain of the function. Okay, of the original function. And so that would be it. All right, and so this is just a recap. Switch X and Y, solve back for Y. We don't really need the plus or minus because that would make it not a function. And then if you wanted to do an input-output, in the original problem, we would input 5 and output 27. Over here in the answer, when we would switch the input-output, the input would be 27 and the output would be 5. That's just kind of a clue that you have indeed the right answer. All right, pause the video and see if you can do that one. This would be x equal negative third root of y plus 6. We are done. Essentially, we just have to make it mathematically pleasing by solving it for y. Subtract x on both sides. You get x minus 6 equal negative third root of y. We have two symbols that we need to cancel. We got to have a negative and we have a third root. It really doesn't matter which one you cancel at this moment. You could do either one. I'm going to multiply both sides by -1 to cancel the negative. And then I would get negative x plus 6 equal third root of y. We've talked about inverses. You should sort of know that we're going to raise both sides to the 3 power, that the third root and the 3 power cancel, and we get y equals negative x plus 6 to the third. You really want to leave your answer like that. I mean, we could expand negative x plus 6 to the third power, but let's not. Let's just leave it like that and move on. There's the recap, switch x and y. That's what we get. And then you could do an input-output that if I input 8 over here, I'd output 4, and then take the answer and input 4, and I'd output 8. It's just a check to see if you're on the right path. All right, last one. This one's kind of tricky. I'm going to go ahead and do this one together. So what makes it tricky is that we have, once we switch x and y, we have 2 y's. And mathematically, the way we're going to get that y to become 1y is by making it the greatest common factor. So let me change color for effect and multiply both sides by 2y plus 3. Yes, that cancels. We would distribute over here. That'd be 2yx plus 3x equals y minus 1. Now we want to collect the y terms. I'm going to highlight the y terms green just because I'm so nice. And then those terms have a y in it. So we want to get the green terms on one side and the non-green terms on the other side. So, well, the way to say that is the y term. So it's 2yx minus y equals negative 1 minus 3x. And then over here on the left side, over here, we want to say, well, y is the GCF. So if we take out y by the greatest common factor thing, we'd get 2x, Take out a y, we'd get 2x minus 1. Darn, I'm struggling. Minus 1 equals negative 1 minus 3x. Then you just simply divide both sides by 2x minus 1. Now, there's a lot of math in there. I went through that kind of quick. And that is something that we'll do in class. We'll spend more time doing that. But that, you could watch this video a couple of times. Let's recap it. That we switched. We solved. If you want to pause, you can read all of that. And then I chose 1 as an input into the original function, and it output -2. And then the answer reverses that. I was able to input -2 and output -1. All right, a good discussion on inverse function and and we looked at several different examples. Feel good about that. Let's check out our cameo appearance of the day. Cameo appearance drum roll is Carl from Sling Blade. Carl actually has a message he wanted to pass along to you guys. Hey guys, this is Carl. I've been hanging out with Coach Sanders up here at the high school. We've had a pretty good time doing these math problems. He taught me a lot of stuff. We went down to Miss Park's room and made some biscuits. I didn't really like them because we didn't have any mustard. We went to Walmart to get some mustard, but they were out. They didn't have any mustard or toilet paper. These are hard times, so I need y'all to hang in there for me. All right, Dan. All right, Carl, appreciate that. See y'all.